The next few problems we're going to be evaluating without using a calculator, and we want to make sure that you show your work. So in order to evaluate without using a calculator, there's a couple of different ways that we can think about this. And so I'm going to go through and I'm going to do both the different ways. One of the things that you can do is you can set this equal to x. And then once you set this equal to x, you can rewrite the log as an exponential. So 2 to the power of x is equal to 16. And then what you want to do is you want to make sure that these bases match each other. So I want to rewrite 16 so that it is a power of 2. So we have 2 to the power of x is equal to 2 to the power of 4. So since our bases match, the only other thing that we need to do is get our exponents to match. So we need x to be equal to 4. The other way that you can think about this is still by doing the bases matching, but without rewriting it. So if you have log base 2 of 16, we can still get this part here to be the same base as this here. So we can rewrite this as a power of 2 still. So this would be log base 2 of 2 to the 4th power. And then we know that logs and exponents with the same base will cancel each other out. And so this log with base of 2 will cancel out this exponential base of 2. And so the answer is just what's left, which is 4. So in this one again, you can think of it as setting this equal to x. So 5 to the power of x is equal to 125. And I want to rewrite this so that it is a power of 5. So 5 to what power is 125. So we would have 5 to the power of x is equal to 5. Now if you don't know, just start multiplying. 5 times 5 is 25. 25 times 5 is 125. So it would be 3 times. So now that the bases match, we just want to make sure that the exponents match as well. These bases don't cancel out. They're still there. It's just that we don't use them to figure out what the exponent is this time. So we would just say x is equal to 3. And the other way that you can think about it would be log base 5 of 125. And we know that 125 written as a power of 5 would be 5 to the 3rd power. So we have a log and an exponential with the same base. These cancel each other out, and the answer would be 3. So 3 to the power of x is equal to 81. We want these two bases to match, so 3 to the power of x is equal to 3 to the power of 4, which means x would have to be equal to 4. The other way is to do log base 3 of 81, and I know that log base 3, 81 could be written as 3 to the power of 4. We have a log and an exponential with the same base. These cancel each other out, and our answer is 4. Last one. If there is no base down here, this is the same thing as log base 10 of 1 is equal to x. So this would be 10 to the power of x is equal to 1. And we know that in order to get any number to be equal to 1, the exponent has to be 0. So anytime that you have a log and the number over here is 1, your answer is always going to be 0 no matter what your base is, because any number to the power of 0 is equal to 1. On the next set, again, we want to do the same thing, evaluate without using a calculator and show your work. So again, we can rewrite 3 to the power of x is equal to 1 over 9. So there's two things that need to happen here. Number one, I need to rewrite this 9 so that it's a power of 3. And I also need to get this base so that it's a whole number instead of a fraction. So let's start off with getting our bases to be the same. So this would be 1 over 3 squared. And in order to get this to be a whole number, we just need to change the sign on our exponent. So this would be 3 to the power of x is equal to 3 to the power of negative 2. And so x would have to be equal to negative 2. Log base 2 of 0, again, 2 to the power of x is equal to 0. So 2 to what power? I can't write this as a base of 2. There's no way for me to multiply 2 times itself any number of times in order to get 0. So this one is going to be undefined. Anytime that you have log base anything of 0, that's always going to be undefined because you can't multiply a number times itself any number of times and get an answer of 0. It's not possible. On 15 is going to end up to be very much like 13. The first thing we want to do is we want to rewrite this part right here as a fraction. So this is log 1/100th. So 1/100th. And remember, there's no number, there's no base on this log, so this is really log base 10 of 1 over 100. And we want to rewrite this number here so that it's a power of this number here. So we have log base 10 of 1 over 10 squared. So this number right here is a whole number. This number is a fraction. So in order to get this number here to be a whole number, we just have to change the sign on our exponent. So again, this is one where we have the base on the exponent and the base on the log the same. So those two cancel out. And so our answer is negative 2. This one is very similar to the ones that we've been doing here with how we have the base of the log and the base on the exponential the same. We have the base on the exponential and the base on the log the same. So these two will cancel each other out, and our answer is just x. Again, we're evaluating without using a calculator. So I can rewrite this one just like we've been doing. 4 to the power of x is equal to 32. I want to make sure that I can rewrite these as numbers that have the same base, so I want to write them as powers of the same base. Well, I can't take 4 to an even power and get 32, so sometimes we have to change both bases. So 4 is the same thing as 2 squared, and then we still have this x at the top here. And then 32 is the same thing as 2 to the 5th. So we just need to multiply these two together, and since our bases are the same, they don't cancel out, we just don't use them to solve for x. So we would have 2x is equal to 5, divide both sides by 2, and x is equal to 5/2. Same thing with number 18. We can rewrite this as 9 to the power of x is equal to 27. Get both of our bases to match. So this would be 3 squared, and we still have the x, and 27 would be 3 cubed. So we have our bases matching. It doesn't mean that they cancel out, it just means that we don't use them to find x anymore. So we have 2x is equal to 3, divide both sides by 2, x is equal to 3/2. Number 19 is similar to the one that we had on the previous page, where we want to change this one into a fraction. So this would be 125 over 1,000, which I believe is the same thing as 1 over 8. So this would be log base 2 of 125 over 1,000, which is the same thing as log base 2 of 1/8. So we can rewrite this one again. So 2 to the power of x is equal to 1/8. I want this number to have the same base as this number. And I also need this number to be a whole number instead of a fraction. So 2 to the power of x is equal to 1 over 2 cubed, but I need this to be a whole number instead of a fraction. So we're going to do 2 to the power of x is equal to 2 to the negative third. Our bases are the same, so we don't use them to figure out what x is equal to. X is equal to negative 3. On the last one, ln is the same thing as log base e. So we have a log with the same base as the exponent. So these two will cancel each other out, and the solution is negative 4. Last set. This one is very similar to the last one that we had. We have an exponential with base e, and we have a log of base e. So these two will cancel each other out, and the solution is 5. On this one, we have to do a little bit of rewriting first. Remember that if you have a coefficient on the log, it's the exponent for your base out here. So this would really be 7 to the power of log base 7 of x squared. And again, you have an exponential and a log with the same base. Those two will cancel each other out, and our answer is just x squared. Log of 10. So anytime that there's no base here, this is log base 10 of 1,000. So 10 to the power of what is equal to 1,000. So 10 to the power of x, I want to rewrite this as a power of 10. So this would be 10 to the third power. Our bases match, so they don't cancel out, but we just don't use them to figure out what our exponent is. So x would be equal to 3. The difference between this one here, where the 2 is on this one, and where the 2 is on this one, this 2 is after the log, and the other one was before the log. So this one we don't have to do any expanding or condensing, but we have e, and we have log base e, which are going to cancel out. And so the solution is just 2x.